Good afternoon, everyone. Welcome back to another exciting day of mathematics. Woo, woo. Warm-up number 55 is on the screen. A couple things to do. It says given 3, 2, 1, 4, 2, compute the measure of central tendency and sketch a box plot. Also for number 2, it says compute the standard deviation and sketch a bell curve. So, get cracking. And by the way, today we're moving on to measures of what? Tell your neighbor. Measures of what? Yeah, position, so we can finish this section off. Let's go. Let's go. Really quick. All right, so let's get started. Measures of central tendency. Tell your neighbor which they are, please, so I can get somebody to get us started. What are they? All right. Let's see. Alejandro, measures of central tendency. Which ones are they? Mean, median, and mode. Median and mode. Thank you. What you get for the oh, my bad. There it is. Mean, median, mode. Pass someone for the mean. Pass someone. Mary, what you get for the mean? 2.4. Hands if you got that. Looks about right. How about the median? Pass someone. Andrea. Oh, Andres. Okay, my bad. Andres, what'd you get? Median. 2. Hands if you got that. Looks about right. Pass someone for the mode. Looks about right. Yeah, 2 and 2. All right. So now that we got that, we need a box plot. Let's see. Pass someone for the box plot. Yeah, start with whatever you use for the box plot. 1, which is the minimum. 1.5, which was Q1. 2, which is Q2. 3.5, which is Q3. And 4 for the max. Hands if you got something like that. That's about right. All right. So far, so good. So I'm going to use the same mean. Everybody know what I mean for this one? Had to do it. You know what I mean? Oh, never mind. 2.4. Tell your neighbor the standard deviation. See what they got. Approximately what? Standard deviation. All right, Andrew, pass someone. Zach, what'd you get? 1.02 approximately. Hands if you got something like that. Who got something different? Maddie, what'd you get? What is it? 1.1 what? Hands if you got 1.14? Yeah, so it depends on which, if you use a shortcut formula or if you did the entire work. It's going to change just a tiny bit. Yeah? All right, so that means our standard deviation is plus 1, I'm going to use 1.02, so this would be 3.42, and then minus standard deviation would be 1.38. Yeah, something like that. This is our normal, or our average range, okay? So below average is that, and above average, all right? So everybody submitted that, yes? Yes, Mr. Q. All right, copy the agenda for today. Agenda for today, warm-up number 55, and we're moving on, measures of position. Let's go, We got this. And tonight's home play, only 2 problems, itty-bitty problems. Woo-wee. Page 159 numbers 10 and 11. All right. Last night's home plate was to revisit the last video lesson, right? Pretty good. Appreciate it. I saw half of you actually go and do it. Very good. So we're moving on. And today is going to be very, very similar to that previous lesson. That's why I asked you to go watch it, because we're going to go pretty quick on that. Okay? So once again, tonight's home plate, page 159, numbers 10 and 11. Okay? All right, copy the objective, please. I can summarize data and compute the measures of position. I can summarize data and compute the measures of position. And like I said, this is going to be the last part of that chapter 3 of data description. You do need a fair model just so that we can keep our organization going as we always do. All right, so measures of position. What are these? Measures of position are commonly used measures to locate a relative position of data, of a data value in a data set. A commonly used measures to locate the relative position of a data value in a data set. So now we're going to start looking at where are they located according to the all the data that we're given. And once we set it up in a standard way, we can find out where they're at. We already did some of this very similar idea to the Chebyshev's theorem. That's why I had you guys watch that video yesterday, right? For home play. Okay, good. All right. So before we move on, turn to your neighbor, let them know what did you remember about that video from last night from Chebyshev's theorem. See if they remember. What is it that you remember from last night's video? All right, very good, very good. Because what if at the end I give you a pop party on that theorem? Hey, let's go. That would be good, right? So you're like, yeah. All right, so what are the measures of position? There's 4 of them. Standard score, percentiles, quartiles, and deciles. Write those down, please. And non-examples, you can write whatever. I'm going to use these. Tell your neighbor what these are as non-examples. What are they called? All right. And for right now, we're going to leave the critical attributes blank in regards to our hashtag, because I do want us to get into seeing where we're going in regards to, I need to actually explain the examples in regards to what they are. Today we're only going to start with the standard scores. And by the way, guys, this one is one that confuses, and that's what I'm saying is that our college folks that I tutored before, they get confused with actually this session. And this session, in regards to standard scores, are also known as, and you probably heard this if you actually look into stats, Z-scores, Z-scores, Z-scores. And of course, if you guys notice, we haven't really used our not a scientific, but our calculators. We just use our basic calculators to compute. So guess what's going to happen with these also? We're going to add what? Let's go, more formula. Let's go. That's what I'm talking about. So commonly used measures to locate a relative position of data value of a data set. Once again, standard scores, percentiles, quartiles, deciles. Today we're only going to start with standard scores and Z-scores, 4 Z-scores. I wrote these as non-examples. You could have written something else. That's fine. So let's move on, yeah? All right. So Right underneath that, I want you to write formulas. And today we're going to focus on the formulas for standard score or z-score. Standard score or z-score. Now, one of the things that I love about this course that we've been doing is refreshing our noodle in regards to the different terminology and the different symbols so that we remember what they are. Does that make sense? So that's why I keep going back to the formulas, and I'm pretty sure you guys are experts at that by now. So here are the two formulas for today. Ready? First one, z equals x minus x bar over s. And the other one is z equals x minus mu over theta. All right, so look at these two. Write them down. And I'm going to give you guys a little bit so you can talk it over with your neighbor and let them know what each part means. What does each part mean? All right? They should know by now. All right? I'll give you some time. So let's see. Help me out with the first one. The first one. This one. What does, well, it's obvious that this is a what? Standard score. Okay, we got that. All right. However, what does this one represent? What does that one represent? Samuel. Okay, so a data set or a value. So I'm just going to write value, whatever that value might be, a score or whatever number they give us. Okay. What does this one represent? Pass on one, Samuel. Mean. Yes, that is correct. I know what you mean. See what I did there? Pretty good, yeah? All right. And this one, so pass someone, Eric? Eric? Standard deviation. Standard deviation. However, it's an S. Standard deviation for what, Aaron? Yes, sample. Bam, from the corner. So now that we have that, tell your neighbor what these represent, please. They should know by now. All right, pass someone, Aaron. Jet. This one. Value. This one. Mean. And this one. Let's go. Yes. Standard deviation pop. And that's what we're going to continue going with. We are always going to be giving two different sets of formulas just to make sure we differentiate one from another. So today, like I said, we're going to start with standard score, or z-scores if you want to call it, and get it to practice, yes? Here we go. Example Q. Copy this one. Bless you. And yes, copy the problem. It reads, a student scored 65 on a calculus test that had a mean of 50 and a standard deviation of 10. She scored 30 on a history test with a mean of 25 and a standard deviation of 5. Compare her relative position on the two tests. Copy that. So there you go. Before we get started with this problem, let's talk about standard deviation. Standard deviation in its term means that standard meaning the mean or the average, deviation meaning how far away from the standard or the mean. Does that make sense? Yes? Okay. So depending on whatever we're measuring, the standard deviation, there's still one standard deviation, two standard deviations, three standard deviation. It doesn't matter what it is. There's always going to be those three. Yes? So far so good? However, what's going to differ is the different I guess, data that we're using. For example, how many, here goes a question in regards to track. You guys know we have the track over there, yeah? How many turns to the track is a mile? 4. So let me ask you a question. Now, I know all of you are going to run the mile, except some, I see some, I remember in Frank Wright, some of you used to walk it. I'm like, really? You guys are walking the mile? My goodness. Question. From those that are walking to those that are running, does it differ that the different laps that they're going to have? No. What's the only thing that's going to be different? The time. But in regards to the 4 laps, there's still going to be 4 laps. Same thing with data. Whenever we're comparing 2 different types of data, standard deviation is still 1 from the average, 2 from the average, 3 from the average, but it's going to differ in the different measures that we're using. Okay? So let's start with this one. So it says, a student scored on a calculus test that had a mean of, scored 65 on a calculus test that had a mean of 50 and a standard deviation of 10. So in blue, I'm going to start with the first part. Start with the first part in blue. Now, question. They're talking only about who? A student. So tell your neighbor which formula you're going to use. Z equals what? All right, good conversations. Yeah. Yeah, tell your neighbor which formula you're going to use before I ask Pedro. All right, Pedro, give me the values here. Hands, have you got that? Yeah, because it's not the entire population, it's only a sample. So with that said, we got Z equals, tell your neighbor what goes what, and do the computation, please. So what is the given value or the given score? 65, that's X. What is the mean? It says here that the mean is what? 50. And our standard deviation for the sample is 10. Therefore, Z equals 15 divided by 10, and that gives us 1.5. Okay, so let's write calculus. Tell your neighbor what goes here. Everyone? 50, yes. What goes here? What is standard deviation? 10. So if we started with 50, this is what? What would be our second standard deviation? And our third? 80. Okay. All right. And on the negative side, we got what? 40. 30. And 20. Okay. So let's look at the position of this person in regards to the entire class. According to the entire class, where is this person at in regards to standard deviation? How many standard deviations? 1.5. So if we go 1.5, so they are somewhere right there. That's their position. This is their Z score for the calculus. Does that make sense? Notice how now we're working on position as to where it's found? Okay. Question. This is a positive 1.5. Tell your neighbor what would have happened if it was a negative 0.5. Talk it over your neighbor. What would it be if it was a negative 1.5? Yeah, it would be on the opposite end, right? So question, here goes the bonus question. Where is the student in regards to the what? The average scale. What would you guys say? Above average. That is correct, because they are found above over here. With that said, I want you to switch colors to red, and I want you to do this next one in red, and then at the end we'll compare it together. So I want you to do the next one in red and do a new bell curve so we can see their position on the next score. I'll give you some time. All right. Patricia, help me out. Z equals what? $30 minus 25 over, oh, sorry. So this is 5 over 5, which is 1. Yeah? Hands if you got 1. All right. So this is for the history. And it's 25. And we got 1, 2, 3. And it's going by what? By 5. So this is 30, 35, 40. This is 20, 15, 10. And this person scored where, guys? Right at the 1 right here. All right. So notice that this is the average range. So what do you guys notice in regards to history? This person is what? Pretty much average. How about in calculus? So this person, if they are one of your friends and you struggle with calculus, guess what? You're going to go and get help from them because they're scoring pretty high. And they are probably in the average for history, so, you know, it's a toss-up. So what can we conclude from both of these? What would you say? Talk it over your neighbor. What would you say in regards to the Z-score over here, their position in class according to calculus, and their position in class according to history? All right. So what can we conclude? Let's see. Who went last, by the way? Pedro, pass him one. Nico, what can you conclude in regards to the calculus position to their position in history? All right, so the student position according to their score is higher in calculus than history. Now, remember, we're talking about position, meaning, let's put it like this. Imagine if a teacher made a list of students that scored at 100% and they started going down the list. This person would be where in regards to calculus? Pretty high on the list, right? Whereas in regards to history, they would be at average. That's pretty much a way of thinking about it. Okay? From 1 to 5, how comfortable are you with these? Yeah? 5, 4, yeah? You got this, right? Yeah? All right. So you already sent in your work. Copy this one. Example super Q. It says find the Z-score for each test and state which is higher. Test A and test B. Copy that, and you should be able to finish this within what? Mel, how many minutes? She said 2 minutes. 4 minutes, 4 minutes. Yes? All right. Get help from your neighbor if you don't see, because all the values are there. You just need to use the formula. Yeah? Yes, I see you. All right. Let's get cracking. Go see. Who can give us a conclusion for this one? Who went last? Nico, pass someone. JC, what can you conclude from test A and test B? So both tests were still within average range, but one of them was lower. Which was the one that was lower in position? Test B, hands if you got that? Yeah. We got this, right? From 1 to 5, how comfortable are you with this? Yeah, we got this. All right, so thank you for submitting your stuff. Quick poll. All right, so we still have about 6 minutes left. So here's the home plate. It's only 2 problems. You get started right now. And from there you can log out once you copy that or take a picture, whatever you need to do. And I'll stop the video right here so I can upload on the YouTube channel. Enjoy your home playing. Bye.